Here's a video to help you with parallel linked lists. We did parallel arrays way back in Chapter 7, but maybe you forgot that by now. That was a long time ago. This is a modified program that I wrote up just to do this particular purpose, to use a parallel linked list. So I'm going to declare a linked list of ints and a linked list of doubles. And then I have two functions, one to get the data and one to display the data, get the data from the user, and one to display it. And for my function prototypes, I'm going to send to the get data function the linked list of ints by reference and the linked list of doubles by reference, and so it can change them. And then for the display data, I'll just send them regular. So down in the get data, I had to make myself a couple of variables as temporary holders, and then I would ask the user to enter an int, get it, and then into the, declare the int list. Where did I do that? Declare, oh, here we go. Declare the linked list of ints and the linked list of doubles, called int list and double list. There, all right. So now we're going to get it in. We'll use the, I'm using linkedlist.h, and I'm using the class version, I think, of it. I'll look and see. And to do the append node method, and we'll append the number we got. You can't use the same variable name, of course, with two different data types, so we'll have another data type and do the append node there. Do you want to enter more? And that's the priming read, and then we have a while loop to get as many others as they wanted. So then that's just a plain old program, except we used linked lists. Now to display the linked list, first of all, I used the display list function that already exists in the linked list header file just to show the numbers. And what that does is, when you call that function, from that function it displays all of the numbers within the function. But this time what I did was, instead of displaying the numbers from within the function, I wrote a function that will go to this function I wrote, send it an element number, so I'm using a counter, and while there are still more numbers, it will retrieve from the function that one value that's at that element number in the linked list and display it out with two tabs. You can see how I set it up with two tabs across the top. So this time I'm having the function only return a single number. And it doesn't print, it prints here, it just sends it from there. Whereas the display list does the actual print, this one just sends it. We might, the display, where's that display list? Just a second. Display. The display list command just sets a pointer, sets it at the head, and then while there are more nodes left to do it, traverses through and does a cout line for the value that's in the node, and then moves on to the next node. This one then expects to receive a position, what we called a position, and expects to return a t, which in one case will be an int, in the other case will be a double. It creates a pointer and a counter, sets it to the head, and then we said, while there are still more nodes in the list, and while the counter that we're on here counting through is still less than the position that we were sent, that we're looking for, just step through. So if we ask for position 5, we'll say 0, is that it? Nope. 1, is that it? Nope. 2, is that it? Nope. 3, is that it? Nope. 4, is that it? Nope. 5. 5. Okay, so once it gets to 5, then, or if there aren't any other nodes, then you would return a 0. Otherwise, once we get to that position, then you would return the value. Hope that helps with the idea of the parallel linked lists. We just did the same commands to the two lists. Oh, I did the get data, so you get data, put it into one list, and then get the other data and put it into the other list. And whatever you do to one list, you do to both lists at the same time with the same element number.